So good morning, everyone. Thanks for being here. Hope it's not, too early in the morning, and we'll do our best to keep you awake. Our talk today is another one of those stories you usually hear in events like this about horizontally scaling something, right? You hear a lot in DevOps events. Only in our case, it's a little bit different. We did migrate a workload from VMs to containers, as you usually do. But in our case, we're talking about the CI workload. Because this is a workload that is often overlooked and not always treated as a production workload. Before we dive in, though, give us a couple of moments to introduce ourselves. So first up,
Hi, I'm Michal. I'm Czech, so if you know any good beer around, please let me know after. I always have development team productivity on my mind. And what it means for me is I cannot touch code physically unless there is a CI. So I will go and build a CI first. And I also work on 3Scale for the last 7 years. That means I have seen something. And go back to you.
And this is me, Yorgos. So I was lucky enough to be born on Crete, and I live there and work remotely for the 3Scale team at Redhat, not IBM. Okay, so let's get that joke out of the way now, nice and early, right? Or at least yet. Yes, but apart from the open source work and community work I do at Red Hat, I'm also involved in a number of community events, open space and conferences, Agile Crete, JCrete, and a couple of meetups. But what I really want you to keep from this slide, if you ever need a work reason to travel to Crete, that's me, I'm your guy. So yes, let's hand it back.
So I probably should give you some background on what 3Scale is and what we do and why even have to do this to actually make our development team productive. So all of you probably did some API management. You used some API keys to connect to some API. But it's not everything that API management is. It's not just about the API keys. It puts the customer relationship. It puts human behind those keys. It means is you need to build that human. You need to send them emails. You need to approve his application. You need to know from where they are from. You need to know their company. You need to have developer portal. What it means for us is that there is a lot of user interaction that we test in the browser, and it is big and slow test suite. So to give you some history before we became IBM almost. 3Scale was founded in 2007 and started as an API marketplace. There wasn't really any, it was probably too early. I joined in 2011 and it was still closed source, SaaS product. We had our private workflow for all the CI pipeline. There was a server in the closet that was running our CI. Then in 2016, we got acquired by Red Hat. And we decided, Red Hat everything Red Hat does is open source. So we started open sourcing everything. And we realized the workflow that open source teams do is a bit different than what you do as a private company. So since last year, everything we do is open source now.
And it was because of this reason, open sourcing was an important trigger for us to kind of rethink our CI. There was one particular case that didn't fit in well. We had a pretty good system in place, don't get me wrong, but it didn't suit this model of an external contributor that wants to contribute to our project, open a pull requests with, get all the tests to run. So we wanted to make sure we lower this kind of barrier to entry for new contributors by investing and building a CI system that can support that. Several enhancements came along the way. Let's take a quick look at what the old setup looked like. It was all on Amazon. And so basically we had a single Jenkins master, but this was the provisioning of this Jenkins master was automated through Makefiles and Terraform. It was a combination, very functional combination of some scripts. So it was fully automated, meaning we could tear it down and bring it back up in a matter of minutes, just basically waiting for the Amazon EC2 instances to spin up and get everything running again. We could do that because all of the Jenkins configuration was in another repo using that SCM sync plugin there. So we had the Jenkins configuration as code, we had the provisioning as code, and we also had the jobs. So the jobs, we were using job DSL, and each of the teams had basically created the pipeline, job DSL and pipeline DSL, to kind of lay out the steps of the build for each of their projects. This was also in source control, so with a setup like this, we didn't really need a kind of an HA setup. Some other important figures at the time to kind of give you an overall idea how this system was used. The team working on this particular project we're talking about today was 5 people. This team, it's important to say that this team was expected to grow. So any problems in this setup, they were only going to get worse as time went by. We were having about 10 or 20 builds per day, maybe some days even more. And people were working on 2, 3, 4 pull requests on any given day. Now this last bit is, I want to stay on this a little bit and explain what it means. We didn't have any bots. What we use now is we have a bot that is monitoring dependency upgrades, so new versions that come out of our dependencies. So Ruby gems and NPM dependencies, these are libraries we use, new versions come out. How do you keep track? How do you stay up to date? Well, there's a few bots. We use one of them called DependerBot, and it opens a pull request on our repository with the new version number every time it comes out. But what this means is that in the background, there are pull requests being opened and test suites being run. So the full test suite runs with every one of these. And we can know if the new version that came out is good to be merged or not. Back then, we couldn't use it. With the setup we had, this would basically flood our CI. But now we can. We'll come back to that.
Right, so that's how the Jenkins master setup worked. But master doesn't really build anything. To actually build our project, we had to use worker nodes. So we were using the 4X large machines on Amazon. They have 16 cores and 64 gigabytes of RAM. They were probably the best compromise between price and their size. So we put 2 Jenkins executors on each of the machines. That means we split the machine in half and dedicated half of it for one executor and second half for the second executor. Each executor had 8 cores and 32 gigabytes of RAM. And the machines were stopped when there was no work just before the end of the billing hour. So we could actually optimize our costs and keep them up as long as they were being paid. But if there was no work, just turn them off. So if the whole team would go for lunch, they would just turn off for 1 hour or overnight and so on. To give you some perspective on what it means slow for us. A warm build is a build that was at least a second on the same set of machines for the same branch. So all the dependencies are there cached, and basically the code is there, and there is nothing to install. It's just going to run the code. It took about 15 minutes if everything was cached and ready, blocking about 11 CPU hours. Because the test suite was parallelized also within the machine running on 8 cores in parallel, if some of the tests would finish earlier than the rest, it would not be accepting more work and just waiting for the remaining tests to finish. It was using about 45 CPU cores and 90 gigabytes of RAM. So if we would add more machines, we would distribute the execution over more machines. But what it means is having less cache locality. So the distribution would be pretty much random. And if you reschedule a build, it can end up on different machines when there is no cache. So it's not going to take 15 minutes, but way more because it needs to fetch dependencies. And when someone else reschedules their job, they are going to have their build on your machine and installing different dependencies and switching every time. So our parallel test suite was a bit Frankenstein. We had 15 manually split tasks that needed to be executed. They were manually balanced across the executors. We had about 5 executors for one job, and each of them, you can see there, that each of them had different set of tasks to execute. Some of them were doing linting code and running JavaScript tests, and maybe running one part of the test suite that was really quick, and the others would be running some part of the test suite that was really slow. And everything was kind of computed by hand and balanced, so they finished in more or less the same time. We also used 4 languages to actually make the build happen. So Groovy to define the Jenkins pipeline and the Jenkins job. Then we really make. So we used make to bootstrap the containers on the VM to start dependencies like databases. And then we used shell to actually bootstrap those containers and start services within them, like squid proxy to prevent connecting to internet, and maybe some DNS mask for local DNS. And then, because we are Ruby shop, it's a Ruby app, we use Ruby to bootstrap the application and run all the tests.
Right, so it might, I don't know if it's coming across, but you might be already identifying some of the problems that we had in this setup, and perhaps some areas of improvement that we could have. But before we go into that, I want to take a kind of a sidestep and look at the motivation about why we set off on this kind of journey of improvement. And the most important thing for us is flow. And when I talk about flow, it's kind of an overlooked aspect of CI systems. I mean, you try to explain to someone what a CI server is, right? And usually you say, or I say something along the lines of, well, it's this server you have running on the background, and every time you push some new code, it will run your tests back there, right, in the background. But the problem is that if you're stuck waiting for your tests to finish running, it's not really in the background, is it? It's very much in the it's in your bloody face. It slows you down, disrupts your flow, and kills your efficiency. So that's why one of the key drivers here was that the CI system, the new CI system that we wanted to build, was something that would sustain flow. If you read the literature, the books about this subject, they all talk about the commit phase builds being able to run in this kind of 5 to 10 minute interval. Make sure that they're all finished. So every time you push new changes, within 10 minutes or so, you know if you've broken the build. This was a key driver, and we'll come back to that. We'll see what we managed to do in the end. But yes, so again, flow, major driver. I even caught a tweet from Dan North the other day who was talking about kind of governance frameworks for systems, and 3 most important attributes being flow, impact, and value, and quality, sorry. Flow, impact, and quality. Optimize for those 3. So this is exactly what was not happening in our case. the build queues we were seeing in our systems were exactly killing flow because people had to wait for, you know, others' jobs to be scheduled. They would land on the different machines, as Michal was explaining before. And it was very, very typical with all this setup to kind of, you know, bring one new node up and wait for that to get provisioned by Amazon and run the tests and then spin another one up. And the build required several of these instances. So it was a common case, not the most common case, but it was a common case for these builds to take upwards of 30 minutes. It's a big problem for us. And to kind of see if you're... So let's have a show of hands. These build queues, which time of day would you think they would be higher? Morning, afternoon, evening. So who thinks it would be morning? Who thinks it would be afternoon? And who thinks it would be the evening? Most people. Right. So it's actually kind of funny because it was the afternoon, but because of what Michal said before. So our team is located in the Barcelona office. Well, most of it, we're not. We both work remotely. But they would often go out for lunch together. And they would come back from lunch together. And when they came back from lunch, they would start all their builds. So it was usually people would come back from lunch and, you know, sometimes even rush to get their builds in first, right? But yeah, so again, this kind of build queues problem, it was really something we wanted to get out of the way. It was made worse by also having this case where, so if you're working on a branch, you've pushed a commit, the builds are running, the tests are running, the build is running, and you decide, you realize you made a mistake, so you push a second change. It didn't cancel the old build. It scheduled another build, just, you know, making things worse. So yes, build queues, one of the problems we wanted to get out of the way.
Yeah, and there is nothing worse than when you come from lunch in wonderful sunny Barcelona, and after 40 minutes you get your build, and then it's red because of some unrelated change. You change some JavaScript, and then Ruby test fails for no apparent reason. So we suffered those. At least, you know, everyone will get at least one failure a day. The tests were executed in alphabetical order. And so if you would add a new file to totally new functionality, it would reorder all the tests, and they would split them to different machines or different chunks. And if they would actually have any dependencies between them, that would kind of exercise it. Yeah, there is.
Share the dependency cache and thanks. Wouldn't it be more efficient if several EC2 machines could share the same storage? They could share the dependencies and so on, and so the code startup time would be much faster.
Yeah. So the problem is the read many, write many access. So we would need to use something like NFS, so multiple machines can actually access and write to the cache. And even like you cannot do it with EBS because it's like one machine mounting the volume, right? And then you need to actually protect from two machines running, writing to the same folder. So only one of them can do. It's pretty complicated to set it up. So we decided it was not really worth the benefit. But yeah, it's would be one of the ways to actually, if you have the time and the power to do so, it's good thing. So it was hard to know if the failure you got was a real failure or just randomness. So people were just retrying the job 3 times to actually see if it's the same test failing before they started even investigating if it's a real failure or not. So rerunning the whole pipeline, because it was very homegrown, you had to rerun the whole pipeline for one test. That means those 11 CPU hours and 45 cores running again. So after lunch, like with this one retry, we get like, 20 builds just in a few hours, and you'll be waiting for an hour or hour and a half. So Jenkins maintenance, it's a, you are depending on it. It's your production system. Your developers are depending on it. If it's down, you are not going to do anything. So it's just another production system, and you need to treat it as such. Your degraded CI can prevent you deploys. You're not going to get your statuses. You don't know if the code is right. You cannot really merge any pull requests probably if you have your flow set up properly. You also need staging if you need to apply major changes. So you need to have an entire second copy and verify that it actually does the same as the first one. You need security updates, and those were, being released pretty frequently. And you need to monitor them, and you be notified of them. You need to monitor that it's alive. You need to monitor the disk space and like everything that's there. And it's very Jenkins specific, but there are LTS releases that are very useful if you are running a stable production workload, but plugins don't have those. So they can basically just push anything and it's going to go to production. And the last problem was our AWS costs. So for this, we were paying about 2,500 euros a month, just in the machines. But the machines are not the total cost. Over my last 7 years, we have invested so much time into making this work. Now, with our current setup with master and all the Git flow and Terraform, we maybe spend like 4 person days a month just updating Jenkins and just spinning up staging and verifying it works. You also need to count the development team slowdown, because developers waiting for CI are juggling tasks. They are going to take another task and start working on it and forget what they were doing before. And then 2 hours later, someone asked them, is it done? Oh, I was waiting for a CI. It's new, I'm compiling thing. People are not really efficient multitasking. Like, I had 2 copies of the same project, so I could have two local repositories with 2 editors and pushing 2 branches simultaneously, just because I was waiting for a CI for half an hour.
Yeah, exactly. So this is, again, coming back to the same point about flow and not disrupting that with CI. And so, I mean, if you look at each of the individual points we discussed before, sure, you can make some improvements to each one individually and kind of improve things. But what we realized was that the kind of the combined problem that all these brought along was not worth kind of investing in improvements, kind of local improvements, but kind of a different way of thinking about CI. And that's when we decided we had to look into other options, look at other CI systems that were there available, systems that didn't require us to do the maintenance. And kind of, that's when we started kind of looking around and evaluating the options. Our kind of shopping list for what we wanted, first we absolutely wanted to make sure that the external contributors would have access to the build information. So if you open a pull request, it's not enough to know that the test failed. Well, I mean, okay, it's good, but because you know there's something to fix, but you need to know, you need to look at the exact logs, see why, and then fix it, and then amend your pull request and send your contribution in. So this was clearly very important. At the same time, our team is definitely by far the biggest contributor to these projects. So it was okay to pay to have the tests from our own team run as fast as possible. So we weren't looking for a free solution. But here's something that people do, and I kind of realized along the way. When you give them the opportunity to run tests on infrastructure that you're paying for, it's a production workload, right? It's compute that you're giving them for free, and some people think, maybe I can mine crypto on that. And so we kind of had this last point that if they do open a pull request where the tests is basically code that is doing something malicious, or mining cryptocurrency and so on, we didn't want that to run in our infrastructure, or at least to pay for it. So then going to the options we had available, there are a bunch of options inside of Red Hat for CI. Well, it's a large organization. And the options there, they range, right? So there is, Michal was talking before about the problem of getting a good version of the Jenkins master with the plugins. Well, there is a team that does that at Red Hat. They give other teams known good, a kind of a managed Jenkins master. So there you get a certain version of Jenkins master plus plugins that and only certain plugins that you can install by default. You have permission to install your own, but then you know how it goes. You have to maintain it yourself. So we had this option of going to one of these systems with a managed Jenkins master, solving some of those problems, or deploy our own. So some other teams would give us resources internally, whether OpenStack, because Red Hat, or OpenShift, again, because Red Hat. So they would give us access to clusters with some resource quotas. In some cases, the resource quotas we got were not enough for the needs of this particular project. But yeah, we did have all of these options to consider internally. The main problem that this was not a good fit was, again, contributor access to information. All of these systems are running behind the corporate firewall inside the Red Hat VPN, so we can't just give access to external contributors. And also, of course, the issue with running malicious code. So then we looked at options for a public CI system. There are several good solutions out there. Circle CI in particular was what we were using in some of the other kind of more light in terms of test suite products. And already using that in 3-scale. So we had the know-how in the team for Circle CI. And we also liked the kind of the focus it had on container builds versus VM builds. Does anybody actually use Circle CI? Yes, just one, two, yes, okay. So yeah, even with Circle CI, there's also a plan that's free for open source, but that wasn't enough for our needs. So again, not an ideal solution, something to be considered. Of course, there was also the approach to go the hybrid route, which is something that some teams are doing. Some other teams inside Red Hat are doing. They will run kind of, let's say unit tests in a public CI. So contributors can still get some feedback on their pull request, but the kind of the heavier integration tests that there are complex compatibility matrices, so you have many databases, many application servers, kind of make sure that your application runs on all of the permutations of those. So that part would probably only run internally. Again, we didn't want to go that way if we could stay on the public option. So in the end, we chose to go with Circle CI. mainly because of the know-how and the cool features that we found it had out of the box. I should say here that none of this is a pitch for Circle CI, and we're in no way affiliated with them. Just their support for open source products is good. We've heard there are more good things coming on that. So yeah. The first thing that we found they solved was basically the access, what we've been talking about all this time, right? So on a GitHub pull request there, you can go to the checks tab, and then you can see here we have an Oracle build, Postgres build, MySQL build, and you can click on this and see the pipeline steps, the status, and you can click here and go over to the Circle CI dashboard. So this is all available, publicly. You can go now and check at this. You don't need any accounts or anything. Well, I guess you need a GitHub account, maybe. So then you can go into the actual build and see in detail the steps, and you click on these and you see the build logs for each of these steps, right? So full access to the build information.
Yeah, one of the very cool features is that we don't have to maintain Jenkins. It's one less production system to maintain, and anyone who ever had an on-call knows that it's a really good thing. And the staging can go with it, so that's also more savings. And no need to check and be worried about security updates and security issues that it could introduce. So one of the very cool features that allow us to parallelize the test suite pretty efficiently is splitting the test suite in a way that it can finish in a similar time. And to do that, it needs to know how long the test suite takes and how each of the files or test classes is taking. To do that, it's using JUnit XML report, which is pretty much industry standard and every tool supports it. And it records the test results. What it gives you is not only the ability to split by timings with some concurrency, but also historical test performance. So you can get all the history and you can see how it evolved over time. Of course, splitting the test suite into buckets by either time or just file name or whatever. Also, it can give you the slowest tests, the most failing tests. It's pretty nice to have history of what you were running. Also, if you have some expensive pipeline like 11 CPU hours, rerunning from some point of time which actually failed is pretty efficient. So some workflows can be really time-consuming, and rerunning everything from scratch would be pretty much useless because we already know that the green ones passed, and paying for them again would be silly. So it actually increases focus on what is failing, and you can rerun just the small part that failed. And when you rerun it, you can also rerun it with SSH. That means you get SSH access to the running container that's running your tests. And like you do DevOps, so you probably know that SSH is a holy grail to everything. It can run shell. It can forward local ports to the remote machine. So if you have some service running locally, you can expose it into the remote machine. You can forward remote ports from the machine to your local host. That, for example, includes X server. So what you can do is you can run your browser tests on the remote machine and see the browser locally, just forwarding the X server to your machine. You no longer have to guess what is happening by pushing some random commits and debugging with echo and finding files. You just SSH, inspect it, and see what's really there. For anyone who actually were developing CI, installing dependencies, and trying to run software there, that's a very useful thing.
Yeah, that SSH feature, it basically had the dev team that started using this, had them, kind of jumping, potting about this, because it's just so easy. The tests fail, you just rerun it in 2 minutes. You have an environment to go debug it. That's it. Nothing to set up on your machine. Yeah. Anyway, so moving on, they also give an API. The UI is it's okay. Kind of limited in some of the things that we wanted to do or to see in terms of information and kind of reports and kind of more insights into how the tests are run. But I do get that we have a pretty complex pipeline, and it's not the most usual case. So yeah, not asking too much, but they do give an API, so you can go and take this information and kind of do your own integrations, and that was a pretty neat thing. And then coming back to the point of the cost of this work, is that we basically went from the 2,500 that we were paying per month just for the machines, plus maintenance, plus development team slowdown. We've now gone down to around 1,200 per month, including basically all of these features. And there's really good reason for that, because for one, pricing is per minute, so it's not like the Amazon per hour hourly billing. Also, all the things that Michal talked about before, with only running the parts of the pipeline that really fail. These are all cost savings in the end, because it makes your builds that much leaner. You can see how much leaner. And also that other thing that I talked about before, pushing a new commit on the same branch automatically cancels your build, the running build, and so yeah. Overall, it just really hammers on this point. You only pay for the builds you really need to. And so we've now gotten to the point, because that's not enough. That doesn't tell the whole story. Because the 2,500 was for a 5-person team without the bots, and now the team is almost double the size. And this bot is like 30%, 25% of our CI comes from the bot that opens the pull requests for the new versions. So now we have basically double the team size and half the cost for running these builds. That's why we're basically going on about Circle CI. But there are some cons, right? So first up is, we do have to pay. It's the free plan that they give out is not enough for our needs. We're trying to put some numbers down. I think for an external contributor, it would take, to run the full test suite, it would take about a couple of hours, 4 hours, 4 hours to run the full test suite for free. So yes, there are some costs. It's definitely, if anybody has been working with Jenkins for a long time, you will get hit by this feeling of, feeling you need to configure more things than it gives you access to, right? So there's definitely that trade-off there. And, well, sometimes for good reasons, sometimes you have to adapt, sometimes you kind of have to compromise on some things and say, well, given the benefit, okay, some things we can do without. It is another company that we have to rely on, so yeah. And, well, again, because Redhat, one of the problems was that it's not fully open source. It's something that we would like for any solution that we pick and rely on, but at least they're very open source friendly, and they have opened up some parts of their source code. So then We'll go now take a closer look at the new pipeline on Circle CI. So this is how the new pipeline looks like. The multipliers next to each of the boxes. I'm not sure why. Yes, there. The multipliers next to the boxes is the parallelism level, right? So basically, this is 40 containers, 1 container, 8 containers, 2, and so on. So when we start a new pipeline, the first thing we do is to fetch the dependencies. This is the Ruby dependencies, and this is the NPM dependencies here. So you can see the kind of the first part, this notify start just sends a message on Slack. And then in parallel with this, we also start a Docker build that just gets a particular Docker build going. So then as soon as these two are done, we can start pre-compiling assets. This is a step for Rails applications. And at the same time, start running some unit tests, RSpec tests. And then as soon as the assets are done, without having to wait for these, we move on to kind of linting and cucumber tests and integration functional tests that you can see, well, clearly here the cucumber tests take up most of our compute by far, heavily dominating, but don't let this number kind of trick you. This is the is how long the slowest container took. So it's not that we had 40 containers of 7 minutes each. They don't. So when you split the test code base and run a certain number of tests on each of these containers, they will finish at different time intervals. It does a pretty good job at balancing, but it's not perfect. So it's not, they don't all finish at the same time. So cucumber tests, linting, integration functional tests, and then at the end we just send another Slack message if the pipeline passed or failed. All this is it's come down to 250 CPU minutes, so down to about 4 CPU hours per build from the 11 that we were paying for before. And actually, just another point. So exactly because we had the dependencies here, Circle CI has this notion of a workspace that you can. It's kind of a shared space. So you keep the dependencies in the same workspace that the next jobs have access to. So if the lint tests fail for some reason, that's why you can go here and click rerun from failure here, and you don't have to go through the entire pipeline again. We can, if somebody wants to look at this in more detail, we will be here for the rest of the day, and you can see it on our laptops. It's open source anyway. So yeah, that's the new pipeline.
So how we got there? It was pretty simple. We just had to run the test 3,000 times and fix everything. So what we found? There was plenty of flaky tests. Flaky tests are tests that could pass or fail with the same configuration, with some external condition. There are various reasons for flaky tests. It could be because they have some shared state, or because of concurrency, timing, or network issues. External state. I won't tell you about those because those are that affect the horizontal scaling the most. As you start scaling the pipeline and start having them running in different buckets, they are going to break differently. So one of the failure cases is dirty state. Some tests require external state, and they are not perfectly isolated, right? They need database, files, some cache, something. And we are humans, so it's pretty easy to forget not to clean up something. And that can cause failures. some tests when they are executed together. So important part is together, because they will work in isolation. But when you execute them together, one of them is not cleaning up, the other one is going to fall over it. Sometimes you can avoid cleaning it up by, for example, throwing away the state. That is case of database transactions. If you run your test suite in a database transaction, and it's a ACID compliant database, you can just roll back the transaction and everything is going to be thrown away. And the other transactions will not see anything that happened inside it. Or, for example, you can create a unique workspace, like creating a project or some namespace for your test and give it unique identifier and having everything isolated for each test case. Other failure is reliance on other tests. So because you execute the whole test suite together and you are not running just isolated tests one by one, some of them can actually prepare something that the others rely on. Like, for example, stubbing some API or setting some global variable. And the others might not do it and just rely that others do it. But when you run them in isolation, it's not happening, so they're going to fail or behave differently. If you run, as usual, it's pretty much default everywhere, your tests alphabetically, they have pretty stable order until you actually add a new test or until you want to run them in parallel to do horizontal scaling. So how do you ensure those tests are healthy and that your test suite doesn't fail randomly? So the first thing to do is to start randomizing the order your tests are executed in. It's going to be painful, but it's really worth it. To actually be efficient doing this, you need to make sure that you can reproduce the random order, right? It's a pseudo-random generator. So there is some random seed, and you have to make sure that your test suite prints that seed. And when you rerun it with that seed, it's going to have the same order. Otherwise, it's not deterministic, and you cannot ever reproduce it. It's pretty easy. Just set up some text formatter and just see the order of the tests. And the second is run it a lot. Run it 100 times overnight, and then 1,000 times overnight, and record failures. Because you will need to figure out what are the most failing tests and in what order they were executed in, and then you will have to reproduce. So how to actually reproduce the failures? How do you isolate them, right? Like if it runs in random order and you don't really know how to do so. So it needs to be deterministic failure. You are not really going to reproduce a timing issue reliably. For that, there are different techniques. But first thing is to reproduce it in your CI environment, right? Like if you can rerun the failed job or task, just do so. If you can access with SSH to the machine and rerun it, do so. And when you know it actually fails again, that's a good thing. Then you try to do that thing locally, like you get the batch of the test that was trying to execute. So it's pretty useful if you can actually print that test files in the log and just copy them and run them locally. And use the same random seed. And then you can just cut them in half or remove a third of them and verify that it still fails. And if it fails, it's a good thing. You're trying to keep it failing and removing things until you actually find those 2 or 3 that are depending on each other. And then you can actually inspect those. So dependencies. Dependencies can take a lot of time to install because it's downloading from internet, compiling. If you're downloading from internet, you can have some internet hiccup issue, something, it's going to fail. So it's really good to have reliable dependencies. Some projects have dependencies in multiple languages, like you have some backend language, and then you have some frontend, and you have to install with 2 package managers, and they can take time. And there is no reason why you should actually wait For the second one, if there are two unrelated languages, like we don't install our Ruby dependencies and then our Node dependencies sequentially, because they have no relationship between them. We can install them in parallel. In our case, cold install would take about 30 minutes. Installing all the Ruby dependencies and compile everything takes about 30 minutes. So we really want to make it faster. So the most common case with external dependencies is downloading them with your language package manager, like in our case, RubyGems bundler. To make it efficient, it's really nice to have transitive dependency locking. So a log file that points to exact revision and ideally also a SHA of your dependency. And you know that this is going to be it. And if there is any slight change, you can, for example, take your branch and then install just the difference. So for caching, you just take your log file and make a digest of it, MD5, SHA-1, whatever. And that's your cache key. And if that changes, you can actually not use that cache and use something else. As I said, you can use a branch. So for example, if I'm not having dependencies for my exact log file, I can use my previous cache I have for the branch. Might be missing just one dependency. And if I don't have one for my branch, I can use one for master. Might be missing 5. But installing 5 dependencies is faster than installing everything. Right. There are also internal dependencies. They are temporary files, like bundled assets, like transpiled files, minified images. And they really cannot be shared with other builds because they depend on your source code and your configuration and a bunch of other things. But they can be reused within one build. So for example, if you have something like we had the cucumber that runs 40 times with 40 parallelism, and there would be a task that takes a minute. If we can extract it and do it before it runs 40 times for a minute, we can save 40 minutes in this parallel build. And that can save a lot of time.
Yes, so then another thing we did need along the way was, again, like we were saying before, some more analytics about how the system is used. So we basically took that API and built our own. Our own. We basically just dumped all the data into an Elasticsearch and used Kibana to create some visualizations. And so it was just a straightforward case of kind of understanding the data, understanding the API, and just kind of create the visualizations we needed. So we now know in total for a specific time period in Kibana how many builds have succeeded or failed, how many builds per author we have. Here you can see the second author is Dependabot, basically the bot I was talking about that creates the pull requests for the versions. And the first guy was working on Postgres support, which was a new thing, and so lots of builds. And then builds per branch. So again, the feature Postgres branch is the one that had most of the builds. And then you can see that for most of the builds here, they're the MySQL ones. So that's what we run most of the time. And then when we have merges to master, we run also builds against the other databases, some visual testing and so on, that we don't always need to run for every push. There are also some more graphs, so we can understand credits usage. So, well, this is going a little bit into financial data, so I've cut those out. But we basically have enough granularity from these from their API to basically know each build, what was the cost of each build, which is a figure that's usually very hard to get to. And then kind of going into the kind of closing and future work for this. We've been talking for a lot of time, so I hope you're still with us. Some of the possible areas for improvement we've identified, and of course, more ideas on this are very, very welcome. So one of the things is the kind of dynamic test allocation on the nodes, or kind of orchestration of the test suite. So we talked before that Circle CI does this time splitting, and so it basically looks at historical data, how long a particular test has been taking for the past runs, and uses that as a predictor. How long is it going to take this time, so I can schedule it and kind of split it into the containers based on historical data. Of course, if you've just gone through some refactoring in your tests or changed something that radically affects how long tests are taking, this is going to be wrong. And so the one approach that we're thinking of kind of maybe moving to in the future is to kind of shift that around so that the allocation doesn't happen before the build, but it's kind of like all the tests are in a queue, and then we have 40 consumers, or however many, 100, and they're pulling tests. As soon as they finish running the test, they can pull another test, right? So a typical kind of producer-consumer pattern. And kind of make sure that all of the containers for running tests kind of finish on the same time, because then let's not forget that in the end what we care about is the developer time. That's the most expensive resource. And those 7 minutes that we had in the Cucumber build, there's actually, I think it's 2 or 3 tests that add a couple of minutes onto that, like real world minutes. We're not paying for it, so it's not, we don't mind the extra machine cost. But when we have that extra 2 minutes for every kind of run of the test, it's a big thing. Another thing we did have in the old system was the Jenkins the build failure analyzer plugin that kind of groups your test failures or your build failures into categories. So this was because of linting. This was because of the tests failed, or the Cucumber tests failed, and so on. So just as a kind of metric, it would be nice to know, which parts of the pipeline are causing the most failures. So maybe we can find ways to prevent those, right? If linting, for example, is one thing that happens a lot, we could have the team do the linting locally before, like as a pre-commit hook. And then, of course, we could go into more analytics, better analytics. I mean, the more you start tinkering with the Kibana graphs, usually you kind of find yourself even creating things you don't really need. But so far, the more we've started showing this to others in our team, the more use cases have been coming along. So then maybe we could use the Elasticsearch machine learning for identifying the test failures and so on. Yeah.
One question, did you explore the idea to start a build on a specific branch before the PRR is actually merged? For example, if you have enough agents available, you could start a low priority build, and it could bring some time savings to the developers.
I'm not sure I'm getting the question, but right now, with every push, we're building anyway. Is that? Yeah.
Before the, sorry, I meant to say before the, for example, if you have a pull request, I mean, it's meant to be merged eventually. So you could start the build as soon as the PR is created,
Yes, we're building on every push to the pull request,
Oh, okay.
or any push. Yeah. Yes. So then, yeah, just more analytics cases in terms of future work. But kind of to close this off, and really thank you for your time and attention this early in the morning. Just one message we wanted to really drive home. Because of all the points that Michal has mentioned, it pays off to put some love into your tests. It's do treat them as you do your production code base. Because you see, the production code base, your clients use it, but in your test code base, your client is your own team and yourself. So yeah, put the same kind of craft that you put in your production code base also in your test code base. I think this is something that could even be like a kind of an addition to, because even frameworks like, or sets of principles like the 12-factor, they don't put enough emphasis on the kind of the test code base as an important aspect of an application, right? So yes, love your tests, they'll love you back. Thanks very much for your time.
Thank you very much, Yorgos and Michal. You can stay here. We have some questions, maybe. We have 5 minutes for questions, if you want. And then, of course, thanks for being here throughout the day. Thank you very much. Any questions? Yes.
I didn't quite, sorry if I didn't get it, but I didn't quite hear how you covered your requirement that, how does Circle CI help you to prevent external contributors to run crypto mining on your CI? Because you said you pay for it, right? So they could still push malicious pull requests, it seems.
Yes, so there's an option there to disable builds from forks. So then they don't run on the infrastructure that you pay for. But if the people still follow your project, I think that's the keyword, they can still build on their own resources. For free, yes. Yes.
You devised an impressive solution of CI. We could see that it takes about 4 hours of CPU time at every pull request. Plus, you run it tens or hundreds of times every night. Now, could you please share with us your thoughts about the ecological impact of such resource consumption?
That's very, very, very good one. We run it 100 and 1,000 times a night, only when we are developing and fixing the test suite. Now we actually, our tests love us back now, so we don't really need to do it now. It's just actually when people push.
And let's not forget that we went down from 11 hours to 4. So it's we've really gone to a much leaner kind of setup here. It's if anything, this work is about reducing waste in the build process. So then I don't know if you want to take it to a kind of a business level about, are we running the tests too often? That's that's a kind of a company policy that maybe is a discussion we can have over a drink later. Interesting. Thanks.
More questions? We still have a couple of minutes.
I wonder if you've had the chance to run your system against non-deterministic systems? And if so, things like neural networks where the results are not necessarily known. You have a probability, but not a 100% probability. And if so, have you noticed any differences between deterministic and probabilistic systems?
So one thing we haven't mentioned, and that was happening to us a lot, but there's a thing we fixed years ago, was we, for example, reference assets on public internet, like from CDNs in our pages. And so the test suite was actually depending on internet and fetching those when running the tests. And that was so unreliable that we had to actually turn off internet during our tests and run them in total isolation, only on localhost, and then use kind of a proxy to pre-cache few things in the beginning of the test suite. But network is the worst enemy of reliable test suite. Like, never ever use network when running tests. That's just impossible to have reliable test suite.